Hi everyone, I am away today, so I just wanted to go over a couple of things. Last class, we learned about the quadratic formula. I did a couple of problems, and then we looked at this toy rocket problem, and I actually didn't get to number 10. So I want to start here. I'm just going to start the question off, and then the full solution is on the next page. You can find this in our class notes linked in Schoology. All right. So if I want to determine the points of intersection of two parabolas, we have to imagine that the parabolas look something like this. One of them is facing up, one of them is facing down. The way we're going to figure this out is similar to what we did in our unit on systems of equations, where instead of, we had two options, substitution and elimination. We won't be able to use elimination here, but what we can do is effectively sub equation 1 into equation 2 by setting the two equations equal to each other. So what we'll do is this. Then what we get is a quadratic, and when we want to solve a quadratic, we need to have one side equal to 0. 5x squared minus 3x minus 7. We can't factor this as far as I can see, so we're going to use the quadratic formula. When you do that, you get negative b plus or minus the square root of b squared minus 4ac over 2a, and then you're going to solve for two values. Once you get those two values, you're going to find the associated y values. Okay, and one of these values might be negative, and that's okay because we're not talking about side lengths. I'm asking you to round to 3 decimal places, so do the work and check it against my solution, which I've already posted. You'll see that the numbers are quite ugly. I've posted a diagram from Desmos that I made, and you'll notice there are actually 3 graphs here. One graph, I believe, we can see here. The red graph is 2x squared plus 5x minus 8. The blue graph is this one. And then the black graph is the combined one that we set equal to 0 and find the solutions of. And I just want you to consider the fact that red has 2 zeros, blue has 2 zeros, and black has 2 zeros. But the zeros of the black function are actually matched up with the intersection points of the red and the blue graphs. So the zeros of the black function are the x values of the intersections of the blue and the red graphs. So that was something I would like to say. Now, for our next unit, lesson 6.2, this is less of a video and more of just telling you that I've posted solutions on our note. I just want to start you off with a couple of the questions. The first one is number 1. To do this, what we have to do are clear fractions and then solve the quadratic. You're probably going to use the quadratic formula. So if you recall, what you're going to do is find the LCD. The lowest common denominator is 3x plus 1 times 2x minus 1, but you're not going to create a common denominator and use it. You're going to clear fractions. So it's going to look, your first line is going to look something like this. Yes, it's a little bit long, but you only have to do it once. And then once you clear the fractions, it's just a matter of cleaning up and using what you know about quadratics to solve it. So after I write this out, I can see that this cancels, and this cancels. Okay, so my next line is going to look nice because there are no denominators. We have cleared the fraction. Okay, so after watching this video, go to my note and you can do the rest and probably use a quadratic formula. Now, the next 2 examples, okay, these guys get tripped up on this on the test because what do you think they do? They just expand it, okay? But what we're going to do is use a substitution. Okay, how does that work? We are going to be smart about our substitution. And don't let x equal x squared plus x. That would be silly. Let's let, I don't know, what's a good one? Might as well stick with y. We're going to swap this for y. Okay, so now if I use this as my let statement, I can rewrite my quadratic. Okay, this is a quadratic. I have y squared minus 8y plus 12. And now, actually, I think we can factor this one. Y minus 6, y minus 2. That's nice. So I know I have two solutions. My first solution is y equals 6. My second solution is y equals 2. But, of course, it's silly that my question involves x and my answer right now involves y. So what I have to do is BS it, back substitute. Okay, so what is that? What I'm going to do is replace y now with x squared plus x. So this is my first solution. My second solution is x squared plus x equals 2. And as you can imagine, we are going to make one side 0 on both of these and then solve. What's nice is I believe this one is factorable, x minus 3, x plus 2, or the other way around, x plus 3, x minus 2 equals 0. And this one, you're going to use the quadratic formula, full solution in my note, okay? Same deal here, but the substitution is a little bit trickier. What we have to recognize is that I can rewrite this fraction as x plus 1 over x plus 2 with the 2 on the outside, okay? And then what I would probably do is let y equal x plus 1 over x plus 2. Then I get y squared plus 2y minus 8 equals 0. Looks very similar to the other one, but anyway, and now we can solve this. Again, full answer in my note. I think the rest of these are quite straightforward. If you have any questions, I think you all are a good resource to each other. I have full answers in my note. And if you have any questions, you can see me in Extra Help next week. Your quiz will be on this stuff. But it's formative, so try your best, and it'll help us figure out what you still need to work on and what I need to answer when I'm back. Okay, everyone, good luck, and please use the class period effectively. Be nice to the coverage teacher. Okay, love you, bye.